Welcome to CBS Easy.
Welcome back. Today, we are diving deep into a chapter that is absolutely crucial for your board exams, carbon and its compounds. We're going to strip it all down to exactly what you need to know to completely ace those questions. It's the big question, isn't it? I mean, this chapter is massive, but scoring full marks, well, that's all about strategy. It's about knowing precisely what the examiners are looking for, and that is exactly what we are breaking down today. So, here's our game plan. First, we'll get into why carbon is so incredibly special. Then, we'll look at its structure and the all-important naming rules. After that, and this is key, we'll focus on the chemical reactions that show up on exams again and again. And to wrap it all up, we'll walk through exactly how we crack a big 5-mark question, step by step. Okay, let's dive in. To really truly get this chapter, you just need to understand 2 fundamental properties of carbon. I promise you, once you nail these 2 concepts, everything else just starts to click into place. The first pillar is a fancy word called catenation. Think of it like carbon's superpower. It can link up with itself over and over and over again to form these super stable chains and rings. Seriously, no other element does this anywhere near as well, and it's the reason we have millions upon millions of different carbon compounds. And hey, this isn't just some random piece of trivia. This is a direct quote, a question pulled straight from your NCERT textbook exercises. This is a classic 2-mark question, and catenation, that's the first half of your perfect answer. And here it is, the second half of that perfect answer. Tetravalency. Tetra just means 4. Carbon has 4 valence electrons, which means it can form 4 covalent bonds. This lets it build these amazing, complex, 3-dimensional molecules. So burn this into your brain. For that 2-mark question, the answer is catenation and tetravalency. Easy marks. So, we know carbon can form long chains and has 4 bonding spots. Now, let's see how that actually plays out. These properties create different families of compounds, and you absolutely need to know the difference between them. Okay, this can be a real point of confusion, but let's make it simple. Look at saturated compounds, the alkanes. They only have single bonds between the carbons. Think of them as being saturated or completely full up with hydrogen atoms. Now, look over at the unsaturated side. Alkenes and alkynes have double or even triple bonds. And those extra bonds, they make these compounds way more reactive, which is a super important detail we'll come back to later. Now for a topic that seems really intimidating, but is actually just a system of rules. IUPAC naming. Seriously, once you learn the system, it's like a code. You can name pretty much any compound they could possibly throw at you in an exam. It's basically a simple 4-step recipe. Step 1, count the carbons to get your prefix. Meth, F, prop, but. Step 2, look at the bonds between the carbons. Is it all single bonds? Then it ends in -ane. A double bond? -ene. Step 3, spot the functional group for the ending, like -ol for an alcohol. And finally, step 4, just put all the pieces together. Theory is one thing, but let's put it to the test with a real exam question. This one is taken straight from a CBSE sample paper, so this is the real deal. Okay, have a look at these 2 structures. The question is simple. Can you name them using the rules we just went over? Take a second, count the carbons, check the bonds, and look for any special groups attached. Let's see how you do. And here are the answers. For the first one, you see 4 carbons, so that's bute. They're all single bonds, so that's -ane. And that OH group makes it an alcohol, so it gets the all ending. Put it together, butanol. Now for the second one, 3 carbons is prop, single bonds gives us -ane, and that Cl attached is a chloro group, which we put at the front. So you get chloropropane. See, it's just following the steps every single time. All right, let's shift gears and get into chemical reactions. There are quite a few in this chapter, but honestly, only a handful are real exam favorites. We're going to zero in on one that pops up constantly. And that reaction is hydrogenation. It's a type of addition reaction, which is a big clue. You're basically adding hydrogen across a double or triple bond. You're turning an unsaturated compound into a nice, stable, saturated one. So how is this actually tested? Look at the wording here from this sample paper. It doesn't just say write the equation, it specifically asks you to mention one essential condition. This little phrase is a classic way for examiners to see who really knows their stuff and who just memorized the basics. And here is the absolute key to getting full marks. Just writing the equation is good, you'll get some credit, but mentioning the nickel catalyst, that's what gets you the full mark. That little Ni written over the arrow is everything. So please always remember to include your catalysts or any conditions like heat for these reactions. We've built the foundation. We know the properties, the naming, the key reactions. Now it's time for the final challenge, the 5-mark question. These look really intimidating, but they are just a series of smaller, connected problems. Let's break one down together. So here we have it, a full 5-marker right from a CBSE sample paper. It starts with a combustion equation and then asks about the hydrocarbons' properties. It looks like a lot, I know, but we are going to tackle this thing piece by piece. First up, part A. The question just wants the values of X and Y for the hydrocarbon. Don't let the letters scare you. This is simply a conservation of atoms problem. We just need to balance the carbon and hydrogen atoms on both sides of that arrow. Okay, let's balance it out. On the right side of the equation, we have 6 carbon atoms in 6 CO2. So on the left, 2 times X has to equal 6. That's simple math. X equals 3. Now for hydrogen. On the right, we have 6 H2O, which is 12 hydrogen atoms. So on the left, 2 times Y has to be 12. That means Y is 6. So our mystery hydrocarbon is C3H6. And see how the question builds on that first answer? The next parts ask for the IUPAC name of C3H6 and the alcohol that it can be formed from. This is designed to pull together everything we've talked about, naming, families, and reactions. Here is exactly what the examiner is looking for, straight from the marking scheme. They're ticking off a checklist. The name? Propene. The parent alcohol it comes from? Propanol. And the related reaction they want to see? Hydrogenation. Hitting every single one of these points is how you lock in all 5 marks. So there you have it, from carbon's 2 unique properties all the way to deconstructing a 5-mark question. I mean, carbon's versatility is the very backbone of fuels, plastics, and life itself. So as you finish up your revision, think about this. What other complex carbon-based molecule that's essential to your life could you investigate next using these very same principles? Keep that curiosity going, and good luck with your exams.
Thank you for watching with us. See you next time.